So we're going to be discussing about the molecular orbital theory. Just a brief introduction. The number of atomic orbitals is always equal to the number of molecular orbitals. So if you have 10 atomic orbitals, you'll have 10 molecular orbitals. Basically, what the molecular orbitals signify, they indicate whether two atomic orbitals are overlapping, okay? And the electrons are spread between these two atoms and are not just for one of the atoms. They're for both. They're being shared. So when you're doing the molecular orbital theory for a compound, you'll find that you are going to be drawing lines on top of lines on top of lines on top of lines. And the way you count how many lines you have is, first, let's draw the compound for this one. Okay. These signify that there is one electron in each p orbital, and these pi bonds are being shared with each other, okay? So since we have 4 atoms, we have 1, 2, 3, 4 carbons, so we're going to draw 4 lines, okay? Then in each of the carbons, there is 1 electron, so we're going to place those electrons on the lines. We'll start with 1, 2, 3, 4, okay? So you add the electrons in each of the levels, and then you'll classify which one is the HOMO. HOMO is the highest occupied molecular orbital. In this case, it's this one. Which one is the LUMO? LUMO would be the lowest unoccupied molecular orbital. In this case, it's this one. So usually on an exam, they'll ask you identify which one is the highest occupied molecular orbital and which one is the lowest occupied molecular orbital, and draw the nodes. So if you say that this is the highest occupied molecular orbital, then you'll have to draw the p orbitals to show that how many nodes are on the highest occupied molecular orbital. Same for the lowest unoccupied molecular orbital. Okay, and so there's another thing you could split a molecular orbital in. You can split them in anti-bonding or bonding molecular orbitals. The anti-bonding molecular orbitals usually are higher in energy than the bonding ones, because remember, if you're having more nodes, that means that your p orbitals are being separated from each other, which means that they are not bonding, and so they're not being stabilized. And when it's not being stabilized, that means that it will exhibit higher energy than if it were to be bonding. So yeah, that's for that. I think that's about what I was gonna say. Okay, I also wanted to show you guys something else. So if you have this compound like so, do you think you're gonna count these carbons or no? The answer to that question is no. Why? Because these are sp3 carbons and they're not overlapping with these pi bonds. If they were to be overlapping with the pi bonds, then you would count them, okay? And you will draw 1, 2, 3, 4, 5, 6 sp2. But since they don't count, you'll only have to draw 4, okay? Hope that made sense. And I'll see you guys in the next video. The next video is about additions of HX or halogens on a pi bond.